Hello everyone, good morning. Thank you all for your patience. I hope we're all doing well. Welcome again to another webinar brought to you by PLM Central Ltd. In today's webinar, we're going to be talking about Creo Generative Design. I'm Kola, the Application Support Engineer, and I'll tell you about the agenda now. So in today's agenda, we're going to do a product introduction. We're also going to look and identify the needs of the product, as well as some of the solutions and the capabilities it can provide, and the value that it brings to a business. There's also going to be the option for you guys to ask questions at the end. You can put them in the chat box. As well as that, we'll put up our contact details at the end, so you can email us if you have any further queries. And I'm going to pass it over to our Senior Solutions Engineer, Muhsin Ali. I hope you enjoyed the webinar. Let's get started. Thank you.
Good morning, everyone, and thank you very much for that introduction, Kola. Okay, so let's get right into it. So what today is about, this webinar we bring to you is all about Creo Generative Design, a new technology that is AI driven, brought to you within your design environment. And it is something that Creo empowers the engineer to create innovatively and quickly. So let's get right into it so we can find out more about this and see how it works and how it can benefit you or your business. So the first question that everybody asks, what is generative topology optimization? And the reason why I say generative topology optimization, because there is a slight difference between generative design. The difference is not about what it does, but it's more about the solution given to a business as a whole, enterprise-wide. So Creo 7 has introduced AI-driven generative design within the Creo design environment. Generative design is a means of autonomously creating optimal design from a set of system design requirements such as loads, constraints, materials, and manufacturing processes. Generative design will unleash digital transformation across the entire enterprise. Generative design capabilities allow manufacturers to drive workforce productivity by proactively addressing user skills gaps. Using generative design, an entry-level mechanical engineer can apply generative, innovative, high-quality designs, solving for specified design criteria and objectives. The solution will reinvent the way the next generation designs are created, eliminating carryover geometry and reducing reliance on engineering experience and expertise. Generative design will allow engineers to explore traditional and advanced manufacturing techniques, helping to create differentiated products, improving productivity, and creating competitive differentiation. Lastly, generative design will help challenge assumptions and deliver innovative, high-quality, manufacturable products. So if you haven't had the chance to read what generative topology optimization and generative design do, essentially is the computer creates your product for you, set out by your design requirements and problem setup. So that's where the constraints loads come in. This will allow you as a business to reduce time to market, deliver innovative and differentiated products, and reduce the product cost as you get more first time right. So that is generative topology optimization. Then we move on to the generative design extension. Now, generative design extension is an add-on to GTO, which is what we just spoke about earlier, and this allows you to work in the cloud. Apologies. So it provides high-performance cloud computing, which allows you to compare, interrogate, and select your optimal design done simultaneously altogether. So what is the main difference between the GTO and GTX? Well, first of all, GTO is a prerequisite for the GTX. So the topology optimization is a prerequisite for the generative design. And it's not always that you need both of them. You may suffice with just GTO, which is the topology optimization that works locally. So it will work for one or two designers that just work on their own locally, and it can all be integrated into Windchill PLM. So all of that product lifecycle management can be monitored and seen throughout the whole enterprise. This will allow you to work on one design criteria at a time, solve for a design at a time, whereas With the generative design, it's more enterprise-wide, it's cloud-based, and it's very powerful, and you can work on multiple design criteria at a single time, allowing you to churn out more results, more options, optimal designs to look at and test to decide which way round you go. So the strategy we have behind generative design is you start off with the setup. Now, Creo users can quickly and easily define and solve for generative design optimization studies using familiar tools to define the geometry, loads, constraints, and the manufacturing process criteria. So selecting all of these will allow you to then start your optimization. And when you optimize, the studies can define one or many design criteria, whether that's cost, whether that's material, that's weight, many other factors that are run independently to produce the optimized geometry. Currently, there are two manufacturing scenarios that define the typical workflow when using generative design. The first scenario supports low volume manufacturing of R&D, prototype, custom, and specialty products. For this use case, manufacturing cost is not a concern due to low volumes and high price premium for specialty and custom products. In this workflow, the results from generative design are directly used for the direct digital manufacturing, so 3D printing of products. Users have the option to work with faceted geometry or use the reconstruct functionality to create a BREP model from the faceted data. And then you can go on to work from there. The second scenario supports high volume manufacturing. So for this use case, there is a need to lower manufacturing costs and increase profits for high volume products. To reduce costs and drive profitability, the result from generative design are recreated and refined in Creo to improve the design and manufacturability of the product. So you can continue with the design, you can run further analysis with the simulation live that we've previously spoken about, and you can work on the BREP model. So as we've spoken before, now with the generative design extension, you can upload the study to the cloud, and then you can see this data. The cloud computing will work and produce data for you that is easily visible enterprise-wide, so you can decide on what is the optimal design. So it's a good enterprise-wide solution. Once you've filtered and compared, you can then go back into the reconstructing Creo design, and then you can do further analysis before you go on to eventually test, manufacture the product. So with every product that PTC provide or come up with, there is always a need that needs to be solved. So the needs we see here, why it is needed, what we've seen through our research, is that we need to speed up the time to market and accelerate the new product introduction. So it is a slow process to design new and bring new products in, and this generative design allows you to do it much quicker and get it right first time. So that leads to reducing product development costs, as you don't have to iterate as much. You can do all of this in the design environment before you pass it on to any simulation engineers to actually see the product and whether it is feasible to manufacture. So increasing market share, sales and revenues to gain early design confidence and mitigate risk. Now this is a big factor, as when it comes, the technology behind generative design looks at factors such as stress, the cost of material, so that it can then create a design that is suitable to your needs. So what do engineers want? They want to deliver designs and get them first time right. And so that is one thing that generative design targets: delivering radical design changes and innovation, and delivering the optimal design to a specified criteria and objective. Now, companies want to deliver breakthrough innovation and have competitive differentiation from other products. So this will allow them to create new designs that will break through in the market that maybe a normal design engineer typically will not see. And these designs are already optimized for cost reduction and profitability. So it works for your business. And then you can create and deliver high quality design and reduce any aftermarket costs with servicing, warranties, repairs, etc. Now, we've spoken a lot about what generative design tackles. Well, let's go through and show the solution in action.
So the next phase of my design process then is to go and create a model. Something that was introduced for Creo 7 was the opportunity to go and create multiple bodies in a single part, and this lends itself really well to processes such as generative design and being able to define which areas are actually required for what processes. So if I go to our new application, this is our generative design solution, and this is different, I think, from topology optimization in as much as we, rather than taking a lump of material and reducing it down, we start off with a prescribed amount of material and work back up. So let's go and start our generative design process. This is where multi-body really comes into its own, because I can go and define some starting geometry, which will be the outer envelope. We then define the preserved geometry, and I know that I just want the optimization to occur within this gray area here. So my preserved geometry will be all of the blue area. So now you can see that highlighted. That means the generated design is going to optimize just in this location here. Once we've done that, we define our loads and constraints. I'm going to say that I'm going to fix in the middle here. I've got a force acting on the two fork locations here, and you can see that I've applied a load of 5,200 newtons in this direction and 3,000 in the Z direction as well. Now this isn't acting straight down, it's coming in at an angle. So if we were to run the optimization, we would end up with something that was more heavily weighted in one side and less so in the other. Obviously this is going to be a symmetrical component, so when I come and define my design criteria, what I can do here is actually say that I want to include a symmetry plane around the middle so that it goes and optimizes with symmetry. Once we've done that, we can go ahead and run the optimization. Let's just turn on transparency and you'll see the optimized geometry growing before your eyes. You can see that it started to run the optimization here, and this is the optimized geometry growing into the area where I said it was allowed to grow. By default, what it's doing at the moment is generating geometry that can potentially have undercuts, because this is something that's going to be printed. If I want to, I can define other manufacturing strategies, such as giving it an extruded direction, such that we could then put it onto a milling machine, avoiding any undercuts. Or indeed, we could also say that it was going to be molded, and what that will do is it will introduce a mold line so that the thing can create a core and cavity for a mold tool. So the optimization has now finished, and I now need to generate some geometry around this tessellated information so that I can go and perform additional downstream tasks. Before I do that, I'm just going to look at the results of this generated design, and you can see what it's trying to do is give us an even distribution of forces throughout the part. If I put the probe over the part at any point, what it will do is it will report back what the stresses are at that location. I can change this into megapascals so I get a better idea of what's happening, and you can see that we're somewhere around the 17 megapascals stress on this green area here. If I want to, other things that we can look at this point, I can go and animate the deformation, and we can see exactly how that's going to react in real life with the forces that I have applied. So we can see the symmetry constraint is coming into effect here, and this is how the forces will bend this component. Okay, so something we introduced back in Creo 6 was the ability within Freestyle to go and take a Freestyle feature and wrap it around an OBJ. That's a tessellated object, and automatically go and create the surfaces. We've now taken that a step further and put that technology into our generative design environment, such that I can now go to generate design, and automatically create a BREP model. I'm going to use the most accurate version of the BREP model, and what it will do now is it will take that tessellated information, it will intersect it with all of the retained and preserved areas such that we get a series of curves, and you can see those being generated now. It says creating style curves, and here they are the intersections between the retained and the generated shape. Once it's done that, it will then start to create the freestyle shapes. You can see it doing that now, and it will start to wrap all of this very complex geometry automatically in these very flexible, curvature continuous, high quality BREP surfaces. And once it's done that, it takes those surfaces, hooks them back up to those intersection curves, and gives us a watertight, solid model, which we can then use in any of our downstream processes, whether that's manufacturing, creating a mold, whatever.
Okay, I hope you guys got to hear that and see that clearly, and it showed and displayed generative design in action with a real life model. Okay, so the next part we move on to is about the business value. What does it bring to your business? And there are a lot that generative design can bring. So it delivers lower lifecycle costs. We've mentioned this earlier, it speeds the time to market and new product innovation, and it designs to realize price premiums. It increases the quality and performance of your product and reduces the product development costs. So that brings us to an end to our webinar. Thank you very much for your time. I hope it was very informative and enjoyable. And I hope this solution has enlightened some of you to think about it and see what it can add and benefit your business. So I'll hand it back over to Kola, who will close off this webinar for us.
Thank you very much, Mush, for that. Very informative and very interesting as well. So here's my email and telephone number. If you guys have any further queries, do not hesitate to get in contact with us. And thank you again for joining us, and hopefully we'll see you again in the next webinar.